Yeah, so Assalamualaikum and good afternoon. So today you have your second class. Sorry sebab I will not open the video untuk savekan you all punya bandwidth. Okay. So it's okay for you all also not to show your video. Okay. So if I ask you some question, maybe you can just unmute yourself or you can just use the chat box. Okay. So one way to reduce the bandwidth during the online class ni adalah by using by off your video lah. Okay. So if you have any problem, you just WhatsApp, just put on the chat box. Okay. Boleh dengar suara saya ke?
Boleh, madam.
Boleh.
Yeah.
Boleh.
So I will close the attendance and then we open again at the end of the class nanti. Yeah. Okay, so for today, first I would like to introduce on Monday I already introduce you the course plan and everything. So I'm sure that you already download in your Ellipse. Okay. So I will give you the detail of the assessment. Okay. So this is your assessment, which is 20% of your overall marks. Okay. So for this project, this is what we call as the sensor project. So this project can be done individually or can be done in group, whichever is convenient for you. Okay. So if you can go and meet your friend, and if you are living in the Unimas campus, you can do the exercise the project in a group. Okay, so if you are located in Sabah or outside Sarawak or outside Kota Samarahan in Kuching area, you can do it by individually, or also you can make it in group as long as you can interact with your friends via the WhatsApp ke, Webex ke, any online conference punya tools lah, Google Meet ke apa-apa lah, as long as you can work up in a team. Okay, so if you have problem connecting, okay, tak apa. Okay, so if you have problem contacting your friend, you want to do it individually, is also okay. Okay, so for this project, at the end of the assessment letter, you will need to prepare a 2 or 3 minutes video, upload it in Elip, and we have a video presentation, 5 minutes, and then some report. Okay. So for this, at the end of the semester, around week 10 to week 14, so I'm sure that this class will finish early. So normally we finish around week 10 already. We will do the presentation. Okay. So make sure that your circuit is running. Okay. And then make sure also if not running, you can upload the video. Okay. So this will be the online presentation for you, which will be assessed by 3 lecturers nanti. Okay, so I will divide you into 3 groups. And then each group will present with a specific lecturer lah. Okay, so you don't need to macam for example, you have your name is in group 1. You can have your friends or your team member in group 6. It's okay as long as you are in the same subject lah. Okay, and then also that one will be online. If you have problem with the online presentation, you can just submit the recorded video to us, and we will evaluate the video and also your project. Okay. Okay, so this is all the assessments that involved in this course. So this assessment is related to each of the COs of the course plan. Okay, so macam you tengok yang previously, we have a course plan, which what is the plan of the overall semester, what you are going to do, what is the assessment, and what is your final task. Okay, for CO number 1 will be the 2 or 3 person in a group. So this one is not salah. The 2 or 3% in group is for your group individual assessment, CO number 4. Okay, so this one will accumulate 20% of your overall marks. You have your CO1 for apa? Individual assessment, individual assignments, which will be posted in the ellipse. Okay, for example, sometimes I will not give you assignments, just a task in the ellipse. Make sure that you did it in the ellipse and submit it on time, and then that one will be calculated as your assessment. Okay, so please join the Padlet or the others Web 2.0 tools actively so that you can get marks lah. Senang je dah dapat 10% from this CO1, CO2, and CO3. Okay, so please also participate in also the quiz and also others activities in the ellipse. Okay. So if you have a problem with your internet connection, no worries, you just inform me. You can do it later as long as you do the submission. Okay. And then this is your task. As engineers, you are given a task to design a sensor project that be able to overcome current problem. For example, okay, you need to find the problem. This for currently, apa tu macam we need to encounter the problem of a car, which is they you want to put a sensor so that it will stop if obstacles at the back of the car, for example. So that one is your problem. Okay, so to overcome this problem, you need to design a circuit which have a IR sensor or motion detector sensor and so on. At least you use one sensor in your project. Okay, and then you need to design the circuit. The circuit is you can get it from the internet. Check the components, make sure that components is very easy to find. Okay, and then do the project. Okay, yeah, so this is the problems. Okay, so you can have a look first. Sekejap. Okay, so you boleh tengok dulu the problem there. Okay, sekejap. What is apa? Here. Okay, so untuk yang lambat masuk, nanti saya akan buka the attendance lagi and then you can scan, or if not nanti saya akan key in manually. Okay, so this is the problem related to your project. Okay, so macam tadi, you are given selected number of components and need to design a circuit that apply the use of sensor. So you may relate it with your daily life. Okay, so this is a must component that you need to have. Okay, so you need to have a DC motor. It's just an example if you want to make a IR or motion detector. car macam tu lah. Okay, so you need to have your holder, everything, IR sensor, the transistor and everything. So this is a must component. So if your component doesn't have a DC motor, it's also okay. It's depend later in your proposal. Okay. Okay, so you can see here your task. Okay, so find your friends, a group, or you can work individually. Okay. And then find the suitable circuit, obstacle detector, sensor, motor. Okay, so solve the problem. Prepare your proposal, submit around week 4 and week 5. This will include objective, circuits, expected outcome. Randomly, you can change at the end of your task. For example, you want to propose IR sensor punya circuit that can solve the motion, the obstacle of the car. Tapi at the end, you come up with benda yang, for example, dia tak boleh detect bunyi. For example, mula-mula you nak design apa yang boleh detect lampu, yang boleh detect bunyi, macam tu lah. Tapi at the end, you just come out with lampu sahaja. Okay, so bunyi dia tak boleh. So bunyi you need to have sound sensor. Okay, so your sound sensor movie dia tak boleh operate ke ada problem, you just can when you give the the motion to your circuit is just bagi you lampu macam tu lah. Okay. So if only lampu, at the end of it tu kena tukar lah you punya report. Okay. So this proposal will be your pre-report. Kalau dia sama dengan you punya final report is okay. Kalau dia tak sama is also okay. You can adjust dia punya detail lah. Okay. So the report is very simple report. Okay. Just a simple that you can you boleh pakai AAA. Okay. Just a simple one. So fill in components, request form. Kalau you ada component yang you nak request, I will give you the form. Kalau yang ada located dekat Kuching or dekat Samarahan, or you have any sister or you are already in Unimas area, you can fill in the form and give it to me via WhatsApp or email. I will get it for you, and then once everything is okay and already sudah ada, I will inform you to collect it. Okay. So if not, kalau yang dah is located outside the Unimas area, outside Kuching, outside Samarahan, okay, you can buy it at Shopee. Okay. And then you need to submit your video demonstration presentation report. I will update you later. Oh, tak apa. Nanti I give you the recorded. Okay. So presentation is around week 14 tu according to group lah. Kalau kita habis awal, we can start early for the presentation. Okay. So presentation is very easy as long as you finish your task. You should be able to get highest mark lah. Okay. Okay, so this is the procedure. Okay. Lecturers give information on the project. Okay, so this one I will not assign you to groups lah. You will select your own group, or you can decide whether you want to do it on your own. Okay, so if you want to do it on your own, you can just discuss with me also. No problem. It's just a simple circuit. Okay, so normally I think this one is also related to your measurement and instrumentation lab 1. Maksudnya ada task juga will be given to you for your lab assignments later. That one is for other topics lah. Okay. And then students will prepare the proposal, submit via link or in hard copy, then wait for lecturer's approval to proceed. Okay. So once you have your idea, you want to make it in group or you want to make it individual, then you prepare a 1-page or 2-page proposal. Okay. So dalam proposal tu, you need to have an introduction, your objective, the proposed circuit you want to design, and the problem statement, what you want to solve. Okay, so you submit it to my email, or I will put it in the ellipse letter. Okay, the link for you to submit your proposal. So you need to wait. For example, this week you already have your friend, or you want to do it individually. Okay, so you ada dah topik, saya nak buat sound detector. which is when saya clap my hand, lampu tu akan buka. Kalau saya tak clap, dia akan apa? The circuit will not operate. So you nak buat macam tu lah. Meaning that you want to design apa tu, macam ada satu bilik kecil. Okay, so student normally dia buat dalam kotak je, and then you put the LED tu, and then you have your sound detector. Okay, so once you clap, ada bunyi, okay, you want to do that one. You nak buat apa tu, sound detector room, macam tu lah. So you have the idea, you can submit it. Kalau you dah ada sekarang ni pun boleh juga around week 1, week 2, so that you can proceed with all the components and you can proceed with all the making of your project. Okay. So the final, the sooner is the better. Motion detector pun ada juga. Okay. So depend dengan you lah. Okay, so the sooner the better, so that you can get your equipment awal lah. Okay, saya sarankan once you dah ada idea nak buat apa, so you just proceed with your idea. Give me your title so that I know what you are going to do. Okay. So week 5 until week 11, or the sooner the better, you will do the task. Okay. Around week 12 until week 14, once we finish the class, the lecture, we will do a group presentation. Okay. Okay, so this is your friends yang pernah buat dulu. This is the racing tournament that I mentioned you previously. Okay, so this is dia punya circuit lah. For this one, they use the Arduino. Okay, so dekat lab kita ada juga Arduino, tapi dia limited. Okay, so meaning that first come first serve lah. This is what we call as the IR sensor untuk Arduino. Kalau you tak guna this one is normally this call it is the ultrasonic. Dia lagi sensitif daripada yang macam LED tu lah. Okay, so this one dia akan connect directly to you punya Arduino lah. Okay, so you have the circuit, and then this is you punya motor. So the motor tu dia akan depend dengan how much supply that you give to you punya circuit. Kalau motor tu you punya supply is not big enough, you punya motor tu tak akan running lah. Okay, so normally student this one is sebab dia kena berdiri sendiri. So normally ada juga yang guna USB, you boleh connect directly. Okay, so that's why kalau you sudah ada benda yang set in mind, you just bagi saya, mana tahu nanti saya akan set up all the things. Dekat lab kita ada semua jenis sensor. Try to list down which sensor yang you nak. Nanti you try to get it for those yang yang nak request lah. Okay. So this is the other one lah. So this small wire is also provided. The one is what we call as the jumper lah. Okay. So this is the battery, and the white one is punya breadboard. At the end, you don't need to do the PCB etching everything. You just plug in your circuit in the PCB. So kalau yang graduated from the poly, saya rasa pernah buat kot. Pernah ke buat benda-benda macam ni? You all? Pernah buat ke? Tak. Tak pernah. Okay, so if you having difficulties untuk buat benda ni, we will just contact me, nanti saya akan guide you lah. Okay. Okay, when you see here, this is you punya breadboard. Okay, so all the components inside the breadboard is, kalau you tengok you punya kaki kaki transistor, kaki ion resistor, dia akan cucuk kat dalam ni je lah. Okay, so this one dia connected selari, maksudnya ini terconnect dengan ini, itu maksudnya lah Aziz. And this one dia connected secara parallel, macam ni lah, kat bawah ni, kat bawah ni. Okay, so untuk yang ke sini is not connected lah. Dia akan connect ini. So meaning that kalau you meaning that kalau you buat the connection, you kena tengok you kena connect the kaki everything. Have problem, nanti akan set the time. Macam mana lah. Okay. So this is the examples. Yang lain tak pernah buat ke? Ada yang pernah buat ke? Tidak pernah. Okay, so ada yang pernah, ada yang tidak pernah. So yang pernah tu, pernah buat pakai Arduino. Yes, you can use your Arduino. Pernah, tak pernah, belum pernah, tidak pernah. Okay, some of you pernah and some of you tak pernah. So detail on the lab, everything, the connection will be guided to you through lab 1 nantilah, which is the KNR1042, the electric measurement and instrumentation. Okay. So yang tak pernah tu nanti contact saya, nanti kita akan buat, we'll try to solve your problems. No worries as long as you can finish your task. Okay. Okay, so this is previously lah, okay, before the pandemic, or everybody is doing the okay. So this is how the class look like lah. Okay. So this is how the class look like. Okay, so remember to submit your proposal by week 4. So your proposal must have introduction, problem statement, objective, literature, and conclusion. Okay. So important, circuit must be designed on breadboard. Yang putih tu is what we call as the breadboard. Your report must include the summary of your project, your circuits, your functions of your project, on flow, how it works. So use at least one type of sensor and you need to have your video demonstration. Okay. So this is all. Sekejap, saya tunjuk you another one. Kalau you have any any question, you boleh tanya directly ya. Ini ke? This is your previously punya lah. This is the example lah. perlu apa? Yeah, so this is we punya seniors punya project lah, okay. So at the end they come up with some things and then they present it. Okay. So this one is before the pandemic lah, okay. So we can have a face-to-face presentation and everything. Okay, for you all, so you need to try it to do it by yourself and try to make it working. It's just a simple, depend on you. Dia punya circuit macam mana, okay. Okay, so this is the example lah. Okay, you can see here. Yang ni adalah a rain sensor. Dia once you letak apa air dekat dia punya apa somewhere here, dia akan bunyikan dia lah, the buzzer. So kalau you tengok yang ada wire macam ni, that one is apa? Untuk Arduino. Okay, so normally they prefer to use the Arduino. This one is apa? When you clap your hand, dia punya lampu tu akan menyala. Okay, so this is home sweet home punya lah. Okay. This is apa? Heartbeat sensor. You letak you punya finger inside. Okay, so this one is saya rasa student ni dia beli dekat Shopee. Okay, so you punya heartbeat detector. Okay, so all the connection here, dia akan guna apa? Beep-beep dia akan menyala kat sini lah according to you punya pulse. Okay. And then right here, there's a car. This is some of them lah yang ada. Sometimes ada juga yang macam untuk motor dia bukakan kipas. Okay, so this is the example lah dia punya circuit. Macam this one is tak jalan sensor. Dia ada apa? Motion and then they turn on dia punya motor untuk tu. That's why you need to find a simple circuit. Dia normally IR, obstacle, temperature sensor, sound sensor. Sound is normally dia pakai apa? Clap your hand. Macam tu lah. So this is our car. This is how it looks like lah. Okay. Depending on students how creative you are to relate it with your daily life. So the important thing is you need to relate it with you punya daily life lah, apa yang you nak solve. Okay, okay ke?
Okay, madam.
Okay, kalau yang ada problem, you can contact me ya. No worries. Hopefully everything will be okay. Okay.
Madam,
Yes.
for the report, right, we do individually or in groups?
If you are in groups, you can make it only one report.
Oh, okay. Thank
You
you.
can divide your task accordingly lah. Okay. So even though you punya friends tu seorang dekat Kuching, seorang dekat Kota Semerahan, seorang dekat Sabah, you can also make in groups as long as you can give them a task. For example, yang dekat Sabah tu dia buat report. Okay. So yang dekat Kuching dia akan buat the circuit and all the video demonstration. Okay, macam tu lah. So you need to work out with your friends. Yeah. Okay, so if no question from you all, we proceed with our chapter 1. So the introduction to instrumentation. So I already uploaded all the notes for this week. Okay, so the activities related to this week's topic is also uploaded. So feel free to do all the assessments and also some exercise that be given to you in the ellipse. Okay. Okay, for this chapter 1, this is just an idea for you what is the instrumentation is all about. Okay, so why we need to learn different types of instruments, either it is analog instruments or digital instruments, and what is the relationship between the electrical and also the electronic instrumentation in your daily life and also in your uh, topics and in your subjects related to this course. Okay. Okay, so the outlines of this topic is for you to get to know the functions and characteristics of instrumentations, what they punya types, what is their functions and everything, the standards of measurements, and also a review of electrical units, all the components related to the electronics components, which is also related to this topic. Okay, so when you go to the lab or normally you can browse from the internet, this is all the instruments that you can see from your lab. Okay, so we have a signal generator, we have a leader instrument signal generator. This is normally analog instrument. This is digital. This is your analog multimeter, and also the famous one is your digital multimeter, where all of the calculation, all the measurements can be done. For example, your voltage, your resistance, and also your current can be done directly by using this simple digital multimeter. Okay. Okay, so this is the measurement definitions. So what is measurement actually? Is for you to be able to compare a value with a specific instruments, either it is accepted or not accepted by the standard. For example, you want to measure the distance. Okay, so the distance dia punya unit is in meter, in kilometer, something like that lah. Okay, so for the height, they are the centimeters, they also the centimeter. Macam tu lah. Okay, they have their own standard. Okay, for example, if you want to calculate the current, you need to know dia punya amperes value. Okay, for the voltage, you have your volt value, and for the resistance, you have your resistance value lah, the ohm, everything. Okay, so we need to have a specific standard in all the calculation for us to be able to follow it. Okay. So the standard could be the frequency transmitted by the government on radio station or a reliable instrument. Okay, so the measurement standard can be divided into two parts. Either it's national or it's depend on the distribution. Okay, so national tu biasa-biasanya is yang kita tahu seperti biasalah, V is equals to R. Of course, you punya value is in voltage, resistance must be in ohm and so on. Okay, for the equipment standard, that one is depend on the companies yang provide that type of equipment. Okay, and then we have instruments, macam is tools for you to do the measurement. We have the multimeter and so on. Okay, so inside the instrument, they have what we call as the measurement, untuk kira the value of the current, the voltage, and so on. So you can see here, if a highly accurate value is required, so your equipment or your instruments must be calibrated. Okay, so that's why you can see that all the devices, before you do the measurement, you need to make a calibration. Okay, for that, so that your results is being accepted by the standard and it is correct lah. Okay. So this is a general form of measurement system. Of course, kalau you nak measure, you need to have a measured value. You have a transducer. So transducer ni is what we call as the sensing element. Okay, so it produces a signal which is related to the quantity being measured. For example, you want to calculate the current, so you need to have a wattmeter and everything. So you need to have a correct instruments to do the measurement. Then we have a signal converter. At the end, you have your display element. So you boleh tengok what is the results and everything at your display instrument. Okay, so what I just told you before, we have two types of standards. Okay, primary and also secondary. Okay, so normally they call it as the national standard. Okay, primary standard is a unique. Okay, so it is the hand of the government. So dia tak boleh ditukar. For example, kalau you nak calculate apa tu, resistor, dia mesti dalam ohm. Macam itulah. Okay. So it is specified by the National Bureau of Standard. You need to follow the standard. Okay, so this is a fix. Dia tak boleh tukar. Okay, and then we have a secondary standard. Okay, so this one is depend on the company yang jual barang tu lah. For example, you have a company yang buat apa? For example, we have Agilent. Dia jual apa? Oscilloscope and everything. So they have their own secondary standard yang only that company yang follow untuk buat calibration and so on. Okay, so that one is what we call as the secondary. Okay, so it's depend on the company. So sometimes the secondary standards is available when you buy that type of equipment. Okay, so they come with some documentation and sometimes they are very expensive compared to the national standard or what we call as the primary standard. Okay. Okay, so apa itu National Bureau of Standards? So it's a non-regulatory agency of the US Department of Commerce established in 1901. So it conducts research and provides the national system if measurements and various technical and informational services to commerce, manufacturing, educational, and also government institutions. So this is the task of the National Bureau of Standards. And then when we do the measurement, we sometimes confuse with the two terms, which is what we call as the precision and accuracy. So is it the same thing? Sama ke? Tak tahu. No, it's not the same. Okay, so sometimes the equipment, they can say that that equipment is precise but not accurate. Okay, so sometimes equipment, they can be accurate tapi tak precise. And then sometimes the equipment can be both precise and both accurate. So this can be calculated using this formula. So accuracy is the 100% minus your error is how close your value to the true value. Okay, and then for the error is the lack of accuracy. So error is 100% minus accuracy. So this is accuracy. Okay, while for precision adalah refers to how many you repeat your measurements. Okay, so that's why when you do your lab task in the lab, so you need to have 3 times, you need to repeat your measurement 3 kali paling minimum to get your exact value. Okay, so this precision can be collected in how many repetition you have. Okay, so dia boleh makin banyak you repeat the process of measurement, makin accurate lagi you punya results. Okay. So for example here, okay, so kalau you tengok orang ni, so a man's height was measured several times using a laser device. So all the measurements were very similar and the height was found to be 184.34 plus minus 0.01 centimeter. Okay. So this is what we call as the precise result. Okay. Precise sebab dia ada 2 titik perpuluhan plus minus. Meaning that this is dia punya errors sama ada plus 0.01 or minus 0.01. So make sure when you do this plus minus, it must be the same with this, the original value, the true value. Okay. But, okay, so you can see that precise is the multiple measurements with same result. Okay, so you have your result which is 184.34, 184.35, 184.33. Itu saja ya you punya result. That's why you dapat 0.01 cm. Okay. Tapi you punya result adakah dia accurate? Okay. It's not accurate sebab dia is not near to the true value. Okay, so why they said that this result is not accurate? Sebab, okay, so dia pakai kasut. Kalau you do the measurement of ketinggian of a person, you need to put your shoes off. Okay, so although the result is precise, sebab dia ada 184.34 plus minus 0.01, but the result is not accurate, meaning that it is not a true value untuk that height of the person. Okay, so you need to take off your shoes to get your accurate result. Okay. So then the man will took his shoes off and his height was measured several times with a ruler. Okay. So ruler tu dia tak boleh give you a 0.01 punya nilai value semua. Dia just bagi you in 1 cm sahaja. Okay. So at the end you have 181 plus minus 1 cm. Okay. So tapi this one accurate sebab dia dah take off the shoes. Tapi dia tak precise. So makin banyak the perpuluhan at the end of you punya result is makin precise your result. Okay. So 181 plus minus 1 cm is not precise. Okay. Dia boleh jadi sebab dia punya nilai is too big to compare with your true value. Okay. So and then the man took his shoe off and his height was measured several times using the laser device. Okay, so by using the laser device, you get the value of 182.23 plus minus 0.01 centimeter. So then your result will be precise and also accurate. So accurate is related to the true value. Precise is related to your decimal places of your final result. Okay, so this is the difference between precise and accurate. Okay. So the precise and the accuracy can be illustrated with this figure, which is what we call as this apa? Yang anak panah ni lah. Okay. The error punya figure. So you can see that from this figure, okay, both accurate and precise. Okay, sebab dia apa? Berselerak di sekitar dia punya true value. The B, accuracy only, is near to the true value. Okay. Tapi dia tak precise sebab itu dia tak sama. And then you see the C is precise. All is the same value, but it's not accurate. Sebab dia berada dekat luar daripada dia punya garisan merah tu. Okay. And then D is neither accuracy nor precise. Okay. So dia tak, the center is you punya true value. Okay. So dia illustrate macam ni jugalah. Okay. So you can see this is accurate and precise. This is not accurate tapi precise. Dia punya result is quite a bit the same. This one is accurate tapi tak precise sebab terlalu jauh antara satu sama lain. And then this is not accurate and also not precise. This is how we illustrate the precise and also the accuracy. Okay. So sometimes the inaccurate, they call it as the systematic error. Okay, so you can see here dia punya figure. This is precise, accurate. This is systematic error. Okay, so although that one is precise, tapi dia tak accurate. Okay. Then we have imprecise, which can be solved by using reproducibility. Okay, reproducibility error meaning that you boleh solve it apa? dia result dia accurate tapi dia still juga dia berselerak sekitar dia punya value. Okay, so this is how we illustrate our figure of precision and also accuracy. Okay ke?
Okay, madam.
Internet okay ke?
Okay.
Okay.
Nota
Okay,
sudah ada kan?
madam.
Boleh download nota kan? Okay,
Boleh, madam.
Okay. So then we have a standard. This standard, since only primary standard can be accepted as 100% accurate, so the concept of error, probable error, tolerance and significant figure must be dealt with. Okay. So kita kena handle. So the important things in doing the measurement is you punya technique. Okay, so technique is how you use it to take your measurement. So it's very important for you to have a good technique. Okay, so dia important juga as long as also you punya accuracy of that equipment and also the standard that you want to follow. Okay. So if you have a proper technique, so you have a poor piece of equipment, that one will also result the not accurate results. Okay, so you need to have your technique, your accuracy, and also the good instruments to do a measurement. Okay, so sometimes an expensive piece of equipment can also give you a poor results if you punya technique is not good. Okay, so you need to have a good technique juga. Kalau equipment tu mahal, still you punya technique is not betul. Okay, so it's no use. Okay. And then you need to be able to know how you interpret your data. Okay, so you need to know for this circuit, you want to measure what? You want to measure the resistance ke? You nak measure you punya current ke? Or you need to know, you want to measure the voltage. So make sure kalau you calculate the current, you know where to plug in you punya multimeter and so on. Okay. So how you want to interpret your data in how many decimal places? Kalau dia punya result give you to 2 decimal places, you need to follow juga. Okay. So when measurements are taken, so it is also important to relate it with you punya data obtained. Meaning that, for example, you want to calculate the circuit, you want to calculate the voltage. That's why you need to relate it with the formula. Kalau you are given specific value of resistance and current, what is the voltage that you need to have? Okay, so that one you relate it with your formula, which is the true value of your result. Okay, so measurement dia akan plus minus with your original or with your true data. So you need to know the formula tu jugalah. Okay. So if the results are unexpected, so maksudnya you punya device tu malfunction lah. Okay. So interpretation of the data could be poor, and sometimes this one is a new discovery lah. Kalau dia still juga you dapat data lain. Okay, so this one is you punya final punya tu lah. Tapi normally is because of the malfunction and also because of how you interpret your data. Okay. And then we have electrical instrumentation. So it is very important in engineering discipline. So instrumentation is the design and use of an electrical system to collect and process physically meaningful data. Okay. Okay, so electrical instrument, they can be divided into absolute and also secondary instrument. Okay. So absolute, it gives the value of the quantity to be measured in terms of the constants of the instrument and then their diffraction method. So meaning that kalau you masukkan A, you akan keluar B. Macam itulah. Okay. For example, for the simple example is tangent galvanometer. So when you put your that meter in the calculations of the current, your circuit, at the end, dia akan give you the value of your current is directly. So you don't need to have a calibration. Okay, so that one is you need to check the deflecting point and also the 0 point of that instrument. So the absolute instrument is very simple. It just give you, kalau input you A, you punya output will be B. Okay, so this is what we call as the absolute. Okay. For the secondary instrument, this device, they need to have a calibration. Okay, so kalau you tak buat calibration, you punya result is not correct. This is normally untuk equipment, for example, as the spectrum network analyzer, the biggest tools that you need to do calibration first, the oscilloscope, and so on. Okay, so without calibration, the deflection of such instrument is meaningless. Okay, so maksudnya you punya result tu tak betul lah kalau dia tak buat calibration. Okay. So all electrical measuring instruments depend for the action on one of the many physical effects of an electric current or potential and are generally classified according to which of this effect is utilized in their operation. So the electrical principle, so this is dia punya different types of physical aspect that's mentioned early in the slide previously. So we have magnetic, lain dia punya instruments, and also lain dia punya measurements. We have electrodynamics, electromagnetic, electrostatic, chemical, and thermal equipments. Okay. Then we have a secondary instruments. Okay, so secondary instruments. So this is all the three types of secondary instrument. So secondary instrument can be classified as indicating instrument, recording instrument, and also integrating instrument. Okay. So this is the indicating instrument. So indicate instantaneous value of electrical quantity. So dia bagi you jawapan on the spot. Once you plug in the probe in your circuit, it will give you the value of the current that you want to relate. Okay, so their indications are given by pointers moving over the calibrated dials. Okay, so meaning that you need to set up your 0 point first kat tengah ni lah, here, before you do the measurement. So normally this type of instrument is what we call as the ordinary ammeters, voltmeters, and wattmeters, all analog instrument. Okay, analog instrument is what we call as the indicating instrument. And then we have a recording instruments. So instead of indicating, this instrument gives a continuous record or the variation of such quantity over a selected period of time. Okay, so they record and then they give you the results at the end of your output. So take the data, record, and then display. Okay, so the moving system of the instrument carries an ink pen which rests lightly on a chart or graph that is moved at a uniform and low speed in the direction of perpendicular to that of the deflection of the pen. Meaning that yang apa untuk orang tengok graph chart on your daily heartbeat, benda tu lah is what we call as the recording. And then we have integrating instrument. They collect your data, they change it into a specific value, for example, in the ampere hour meter and also in watt hour meter. Okay, so measure, register by a set of dials, and at the end, it will give you the total of amount of energy that will supply to a given circuit in a given time. So this one will give you in ampere per hour meter and also give you per watt per hour meter. So we have three types. Indicating is instantaneous, recording is record the data first, and then display. Integrating is you integrate your input value to a specific new value. Okay. And then we move on to a review on the electrical units. Okay, so this is just a theory for you to understand. So electrical current I is a flow charge carriers. So therefore, your units of current and charge, Q is the electric charge that pass a given point in a conductor during a time of 1 second. And the column C is the unit of electrical charge or quantity of electricity. So when you deal with the electrical units, you need to know the Q and also the C. Okay? So thus the amperes is equals to coulombs per second. So since one coulomb is equal to the total charge carried by 6.24 times 10 over the power of 18 electrons. So therefore the charge carried by one electron is equals to 1.602 times 10 over the power of negative 19 coulomb. Then we move on to the EMF, electromagnetic force, and also potential difference, which is represented by V is volt. Okay, so 1 EV is equal to 1 divided by 6.24 times 10 to the power of 18 Joule. Okay, so 1 EV is equal to 1 electron moved through 1 volt. And then we have a famous one, we have resistance and also conductance. So R is 1 over G and G is equals to 1 over R. Okay, so the ohm is defined as the resistance which permits a current flow of 1 ampere when a potential difference of 1 volt is applied to the resistance. While for the conductance is the vice versa of the resistance and the value is given as the Siemens S. Okay. So this is different types of electrical resistors. Normally we use this one, the fixed carbon that you macam ni lah, fixed carbon. So the colors representing the value of the resistor and also the tolerance. Okay, so the tolerance tu adalah dia punya accuracy of that resistor. Okay. We also come with this one, the potentiometer, and sometimes we use the rheostat. So this is all the value of the electrical resistor. Then we have a magnetic flux and flux density. Okay, so no worries, you just calculate a simple formula saja untuk this course for this magnetic flux. You will learn on detail on the EMF when you come with your, when you study about electromagnetic theories later in the other syllabus lah. Okay. For the magnetic flux, you can see that it is represented by what we call as the Greek letter phi. It's a measure of quantity of magnetism, taking account of the strength and the extent of magnetic field. So the SI unit is equal to Weber, which can be derived in volts per second. And the unit of magnetic flux density is normally they call it as the Tesla or Weber per square meter. Okay. So this is how it illustrates the how the magnetic flux will penetrate through the given surface area. Okay. Okay ke? Okay.
Okay, madam.
Okay, madam. Okay, madam.
Okay, madam.
So this is how it looks like. The magnetic flux density at a closed surface. Okay, so no matter how small the value, the magnetic sources are always dipole sources. Okay, so meaning that they need to go to the north to south depend on the flow of your magnet. Okay, so this is how it illustrates how the electric field and how the magnetic field will produce in the given diagram here. So this is dia punya integration of the magnetic flux through a given surface. So don't need to don't need to emphasize in detail here because you will learn your other courses, just a brief sahaja, okay? And then we have the inductance is a behavior of a coil in a resisting any charge of electric current through the coil. So it follows the Faraday's law, and this is dia punya given formula for the EMF of the inductance. Okay. So the unit of inductance is normally we call it as the Henry. So this is the punya formula. We have imperial formula and also metric measurements formula. Okay, so no need to remember, just tengok sajalah. Okay. And then we have a capacitance is a measure of the amount of electric charge stored for a given electric potential, where C is equals to Q over V. Okay, so Q is you punya charge, either it is positive or it is negative, depend. And V is you punya voltage between that charges. So the unit of capacitance is 1 farad, which is representing of 1 coulomb per volt. Okay. Then we have a temperature. So normally we calculate it with the Celsius scale, 0 until 100 degree. And you can change it into Kelvin scale, which is what we call as the absolute scale. For 0 degree Celsius, it is equals to 273.15 Kelvin. Okay. So this is the unit conversion factor. So 1 inch is equal to 2.54 centimeters and so on. How you convert it from one unit until to another unit. Okay. So another metric conversions given by the US customary measurements is also the same. So itu sahaja untuk the introductions of the measurements and also the instrumentations. Any question? Jacob?
No, madam. All clear.
Okay, all clear. Okay. So you can go to Ellipse and then I already post some activities for you. Okay, so measurement standard history. This is apa? The videos. Okay, so you can take a look and then this is all the details of extras for you to understand this topic. So you can go to activity. Please go to this. Yang lain boleh access ke? You can go to your quiz. Buat ke? And then please answer the questions. So this quiz will end up at tomorrow, 15 October at 8 PM. Okay. Saya dah tengok ada 12 orang dah jawab. So kalau dah siap, you can go to your others activity. Okay, so you have 3 activities there. So please feel free to do it in the given time. Okay, so I give you time to do the activities that been assigned to you until 1:30. Okay. After you finish, you boleh apa? Leave the class lah and prepare for your next class.
The all three activity or activity one?
Yang punya. Yeah, so please do all the activities. I will give you until 1:30 p.m. Okay. So after that, we'll discuss the answer. So if you have any question, you can just directly type in the chat box. Huh? Okay. Okay ke? Okay, so in the exercise, there is no right or wrong answer. Okay, so it's depend on how you interpret your answer. As you can see here, so this is okay, the question is given to you. Okay, so some of the answer is here. So what is the indicating instrument? Is one which simply measures a quantity and indicates what the quantity is. So example are thermometers, voltmeters, pressure gauge, and the greater proportion of instruments are of this type. So kebanyakan instrumen kita adalah dalam this type of instrument lah, indicating. Okay. Then we have recording. So you need to bear in mind these three important definitions of the instruments lah, sebab dia akan selalu keluar dalam yang punya exams letter. Okay, so we have integrating instrument and so on. Then you have this type of figure. Okay, so this is dia punya apa? Sekejap. So ni tak ada sangat. This is definition untuk yang last part tadi yang tanya pasal environmental errors. Okay. So this is random errors and also systematic errors. So environmental errors they park under random errors. Okay. So dia adalah change in temperature, everything is related to our environment lah, which is randomly calculated. Okay. So systematic ni adalah more kepada equipment itself, sama ada equipment tu ada faulty, aging errors and also insertion errors and so on lah. Okay, so this is dia punya common sources of errors. Okay, so you go back to your exercise. Okay, so this one you can see that from the figure. So same lah. Yeah, this is your punya question. Okay, so this one is not accurate and not precise. Bear in mind. Sebab apa dia tak accurate? Sebab dia tak near to the true value. Sebab apa dia tak precise? Because dia punya data tu randomly. Tak apa? All together. Dia punya plus minus errors tu tak kecil lah. So this one cannot be said that this precise tapi not accurate. Kerana dia not precise, not accurate. Okay. So B adalah dia precise tapi dia tak accurate. Sebab here is you punya true value tapi dia tak letak near to this one. Okay. For C is you punya precise and also accurate. So you need to bear in mind the definitions of these three. Okay. So then you have your calculation. This is the common sources yang saya bagi tadi lah. So the calculation is based on you punya formula which is already ini punya nota tu lah. Okay, so this is you punya answer lah. Okay, as long as you have a true formula. So ni kenapa Nura Aini dapat 1.499? So please check again lah. Okay, so normally we have this one is 5.02. Kenapa dia 15.02? Y is 0. Okay, so please check again your punya formula. Then the formula of this one. Second one is for the calculations of the Siemens. So this one is 2.403 times 10 over the power of negative 15. And then we have calculate the conductance, just vice versa. And then we have this one, capacitance value, 10 to the power of negative 18 divided by 10 volt. Okay, so this one plus 273, you get your answer. Check again with your answer. So please, if you have you can copy the question here and then plus please try to do it again if you have kalau ada salah. So you cannot edit here. So never mind if you wrong here, tapi as long as you punya on notes, you try to do the correction. Okay. And then we have another one. Activity 1, this is second one. Bukan. This one. The definitions of the instruments, give an example, macam itulah. So sensitivity can be defined as an absolute quantity where smallest amount of change can be detected from the instrument. So higher sensitivity of instrument result in highest accuracy of the range recorded. Okay, so this one is a good answer. Okay. Okay. Threshold value that start at 0 do not have output change that can be detected by the input change gradually. Threshold value from the graph does not start with 0 but instead start from a negative. So you can see here from you punya tu, define the threshold value. So you punya threshold value is located kat sini ya. Ni. Jadi tak boleh cakap dia start daripada negatif sebab you punya graph start dari positif, cuma dia teranjak sedikit daripada dia punya 0 point. Okay. So meaning that where is the threshold value is when you punya graph to start at the axis of x. Okay. Coding instruments, integrating. Ni bukan short pulses ni bukan. The bottom end of the line. Peak value kan, threshold tu dia adalah benda tu tak start daripada 0. Ingat tu je lah. When y is equals to 0, y equals to 0 boleh, tapi be specific on the starting of the graph to itself is also okay. Increasingly bukan, you need to define where is the threshold is located. Okay, so yang tak siap lagi, you can finish your punya task. And then another one is you punya take home. If you already finish, you can proceed with other activities. I will give the answers during our class on Monday. So here is your punya activities. This one. So please try to calculate it and find all the answer. Okay. So the nearest cm meaning that you kena tengok you punya here. So if your value is given as 80 centimeter to the nearest centimeter meaning that you punya accuracy adalah 80 centimeter plus minus 0.5. Okay. 0.5 centimeter plus minus. So that one is maksudnya nearest centimeter. So normally student dia confused. Dia letak nearest centimeter is 1. 1 bukan nearest centimeter. We use as a 0.5. Kalau that one is 1 meter, so you cakaplah 0.5 meter as you punya accuracy. Okay. So try to do first. So if you have problem, we will discuss it later. Okay, so try to tengok macam mana thermometer measures to 2 degrees, calculate the accuracy, absolute error and so on. So any question?
No question.
This one is okay. So this one is related to yang orang berdiri tu lah. How they calculate the accuracy and also dia punya absolute errors and so on. So try to do first. Kita akan go together on Monday later lah. So I will upload the detail of you punya project task later in the ellipse. Okay. And then now, please find your friends. If you want to do it individual, it's also okay. I will upload the form to collect if you want to request component. Okay. So dekat lab tu dia normally we'll need to check first lah sebab small component need to check. Yang sensor tu Arduino is sometimes we have. Okay. Nantilah kita tengok macam mana what you want to request. And then if you want okay, itu sajalah maksudnya. I need somebody, you can discuss among you punya friends, siapa yang akan jadi pengantara antara saya dengan you all. So message me and I will deliver some information kalau ada apa-apa yang urgently needed by you all lah. Okay, so you discuss with your group. I am sure you have you punya group kan. So cari seorang leader untuk dia contact saya directly lah. Okay, so that leader akan convey my message to all of you so that I don't need to go inside you punya group lah, nanti you boleh discuss among your friends. Okay. Okay ke?
Okay, madam.
Okay, rasanya tu sajalah yang tengah buat tu. You can proceed with the exercise. So we end our session today around 1:35 lah. Okay, so just give to you to release your head first before you punya next class. Nak makan ke, nak solat ke. Okay, so see you all. This topic is not a tough topic. Hopefully you can get very good marks lah as long as you follow all the instructions. Okay, so thank you. I will share again the QR attendance for you.
Madam,
Yes.
where can we submit exercise 3?
Exercise 3 yang saya suruh download tadi yang ada thermometer tu ke?
Yes.
That one no need to submit. We will discuss the answer on Monday. We just buat dalam paper saja. Okay. So yang dah scan, if no more question, you can leave. Thank you very much. Assalamualaikum.
Alright,
Madam.
madam.
Thank you,
Thank you,
madam.
madam. Thank you, madam.
Madam.
Thank you, madam.
Thank you,
Salam.
madam.